Hello everyone, today I'm going to deliver another lecture which on load combination as per ASCE 705 or BNBC 2020. So mainly there are 7 load combination which is 1, 2, 3, 4, 5, 6, and we'll show how it is divided in 31. Let's see, we'll see in detail. So these are the main load combination we've been seen here, 1, 2, 3, 4, 5, 6. So we've been seen number one, 1.4 dead load plus flood. In our Bangladesh region there is no flood, that's why we are deducting. If you in this region I am belongs to, I'm living. If you are living in another, which is Saudi Arabia or Egypt, Qatar, Afghanistan, this also valid. If you live in Western country, Germany or USA, then you can use flood and other things, which is temperature, heat, rain. It will be considered for region to region. Okay, so I'm taking this 7 load combination is here. So these are the 7 load combination have been seen here. So we've been seen 1, 2, 3, 4, 5, 6. So as per at first we see 1.2 dead load plus flood, 1.2 dead load flood plus temperatures plus 1.6 live load plus heat plus 0.5 LR means floor load, and W is wind load, E is earthquake load. And with this we've been seen a 7 load combination here. So now we will divide here. We'll divide here. So let's see. Then number 1 is as usual. Number 2 is also same as it is. Number 3 we've been seen live load or 1.8 wind load. So we are dividing here. So we are dividing number 3 load, serial number 3 we can see here. Number 3 is divided into 2. One combination is for one live load we have been taken here, 1.2 dead plus 1.6 roof and 1 live load, and another combination is 1.2 dead, 1.8 wind and 1.6 roof load. So that's why we are dividing two. We are dividing this combination into these are the two combination. Okay. And we can see here the earthquake. As we know, the earthquake is divided 3. One is X. We know the earthquake will be appeared is we if we want to calculate. I'm seeing here. I'm taking a paper for a better calculation. Okay. So these are the earthquake number 5 load combination. So earthquake is divided into 3 zones. So in earthquake we know the earthquake will appear in like this way and goes this way. So it will be x in horizontally x-axis and y-axis and vertically also. So it is gone in x-axis also, it is gone in vertically also, so it can be gone in y-axis also. So that's why we'll divide in earthquake load in 3 axes. One is x-axis, another is y-axis and vertical axis. So we'll see all together how we'll get this. Okay. So as it's 7, so we are not dividing here, we're just saying how the earthquake load is divided in 3. That's why we are taking here 3, and live load is coming taking here, and these are the plus minus, these are the plus minus, and this is the plus. Okay, let's see. So number 1 combination as it is 1.2 dead loads, and number 2 is 1.2 dead loads, 1.6 live load and 1.5 roof load from here we have been seen in the previously, and then 1.2 dead load live load and 1.6 roof load as it is coming for from 3 combination from 3, and another we have been seen here 1.2 dead load 1.6 live load, and we are taking the earthquake wind in two direction, in positive and negative. So if we as per we know that when the building is affected, if a building is stable here, so one load is coming here in x direction, it will be y direction, and another is x direction. These are the x direction, so we have to consider building in both direction. That's why we have been taking x positive and x negative. Okay. uh, uh, okay. Okay, so if we calculate in it will be sorry, I'm interrupting again. We have to if you visualize this the building in 3D, then uh, you can understand what is the x-axis in positive and negative. Okay, so you've been seeing this is the x-axis. Okay, these are the x-axis in positive x, and these are the negative x, and on the other hand in this surface will be positive y, and on the other hand this surface will be negative y. Okay, that's why I'm dividing here the positive x and minus negative x, and also positive y and negative y. Okay, these are the combination we have been dividing, just this combination, 1.2 that, so that's why 1.2 that, and 1.6 roof load, 1.6 roof load, and zero point 0.8 wind load. So we are dividing wind load in three direction as per our as per our requirement, as per our location, as per our direction. Okay, so number 4 we've been seeing here. Number 4, these are the also wind load. We've been seeing 1.2 dead load, 1 live load, 0.54 roof load, and 1.6 wind load. So the wind load will be divided as it is. We've been seeing 1.2 dead load, live load, and this for 1.2 dead load, live load, and zero point 0.5 roof load, and wind load also divided in as per this direction we've been seeing here, positive x, negative x, positive y, and negative y. Okay, positive x, negative x, and positive y, negative y. Okay, now we've been seeing the another load combination which is here. This we've been seeing the earthquake is divided as we've been seeing. This is the earthquake is divided into x, x, y, and vertically. If we want to understand here, I'm just erasing this. So we've been seeing here the earthquake is affected. So I'm just roughly drawing the building here. You have been seeing here the building, so 3D building. Okay, so when earthquake is affected here, so the earthquake is going this way. So we can see in the earthquake direction, the earthquake will be this affected in the x direction, and it will be affected in y direction also. These are the y direction, and affected also vertically, which is a z or vertical direction. So horizontal 2 direction and vertical 1 direction. That's why in this earthquake we have been divided three zones. So let's see how we'll get this. So we've been seeing the earthquake is divided x-axis and vertically. So how we'll get this? So we have to go to the load combination here. We've been seeing here by the way, we're doing this load combination for only for load combination seismic design category C, vertical B and D. Okay, so let's see here. So these are the information we've been seeing. The structure is seismic design category C and D shell. The minimum configuration requirement for seismic design category B and the additional requirement of the section. And this structure is given in C. So when we calculated seismic design category B, then we will not taking this 100% or 30%. When we calculating seismic design category C and D, then we will consider 100% and 30%. So let's see. Here the seismic design category D shall be designed for 100% in horizontal seismic forces in principal axis with combination 30% of the horizontal seismic force. Okay, so all the horizontal axis is given here, and the orthogonal, which is called orthogonal direction, and possible combination we've been seen here 100% x direction plus minus 100% x direction and plus minus 30% y direction. What does mean it? This mean it is this. At first we have been taking plus ex 100% and 30% mean 0.30 ey, and then plus ex and then minus ey, and then minus ex plus ey, then minus ex and minus ey. These are the first direction, and another condition is given 30% is x direction, plus minus 30% x direction, and plus minus 100% in y direction. So we have been seen here plus 0.3x and minus plus 1 ey, plus 0.3x minus 1 ey, then minus 0.3x plus 1 ey, and minus 0.3x and minus 1 ei. These are the, we can see the 10 combination is coming here. Okay, so it will I am wrongly write it here, the 3 into 3, but it will be 4 into 4. So 4 plus 4, so it will be 8 combination will be coming extra for dividing in this for these cases. So we have been seen here, this is the 4. At first we have been taking this 4, and another 4 is here, this is the 4. So we are taking this 4, and now we are going to explain our vertical will be coming here. This is the vertical. I am not calculating here as we have been seen here. So so ex ey, these are the completed. Now we'll see the how we'll get the vertical axis, and by the way I'll show the how we'll get the vertical explanation. And as it is, we have been seeing the number 6, which is wind. We have been seeing the wind is already we have been seeing the it is working ex, and previously I have been seen here in x direction plus and x direction minus and y direction plus and one direction minus. That's why I'm not seeing I'm not drawing again, rather than focusing the earthquake. Okay, so we can see here another combination is 7. We can see here the earthquake. So if we found the earthquake, then it is obviously count ex ey and vertical as it is. So we've been seeing ex ey and vertical. So we are seeing here the same amount we have been found, and previously I have been shown here. So we are putting this here, and second and then another fourth combination also I am drawing here, and vertical is as it is running here. So remember it, we are taking the negative value EV, and this is the positive value. Why? I'm just saying okay, I will just explain later. Is not later. When I'm calculating EV, then I will show. This is the important. Okay, so let's see if this in this we can see as it is we have been seeing the load combination 1 is as it is, 2 is as it is, 3 and 4, 5, 6 all are as it is taken. Now we can see how we'll calculate the vertical, which is EV. So now we'll go to the here. This is the vertical earthquake. We can see the maximum vertical ground acceleration shall be 50% of the accepted horizontal peak ground acceleration, and vertical seismic load effects EV can be determined this formula 0.50 AB into D. What is AH? AH is nothing but AH is 2/3 Z into S. What is Z? Z is the seismic zone coefficient, and S is the soil site class soil site class dependent on the soil factor. So if we go to the another these are the value of okay, these are the value of SA value site class. If we go to the zone value, then we have to go 7, 6, 9. So if you go to the Z value, so now see how we get the Z value. Okay, these are the Z value. This is one of the seismic zone. If the seismic zone is 1, then Z value will be 0.12, and for zone 2, then value will be 0.20, 3.28, and for 4, then value will be 0.36. This is the intensity we have been given here, but you will get from here also, but this is the most common scenario. That's why I am taking all the values here, seismic zone coefficient with respect to C. And another one we can see here, site classification. We have been already seen here the site dependent soil factor and other parameter depending on elastic response factor. So these are the soil type, and this is the S value, which is the soil site factor. Okay, so we'll apply this in our okay, so sorry for interrupt. So I'm going to here. Okay, and in this way we'll get found the Z and S value. I have been seen here how we'll get this value, and putting this value is here. Putting value is this here as so far we can see the Z value coefficient is 0.2, and we've been seeing the soil site class is 1.35, then the EV will be 0.90. If we're calculating here, we're just putting the all these value is here. I'm just already calculated here, and then the value will be 0.90 into DL. This is the DL, which is dead load, or DL we can see here is the effective dead load. So dead load will be here. So in this dead load we can see this EB value will be this here 0.90 dead load, 0.90 dead load. As we have been seen here, EB the value of vertical earthquake, all the vertical earthquake value have been found calculating just using this formula, and found the vertical earthquake load. So we are just putting all these value here. Okay, so now we will see now we can minimize, we can sum adding this and dead load with this point. So if we if we this add 1.2 plus 1.09, then will be total dead load, and in this way we will calculate 2.9 dead load minus 0.9. Why will minus? Because in these cases given the it will be minus and it will be plus. So why? Let's see. here this is the seismic event and including overstrand factor. So if we see here for using in load combination 5, so this is the 5 load combination, this is the 5. Okay, so if you calculating in load combination fund 5 and section 3 and the load combination 5 and 6 section 2.720, E shall be taken equal to EM as determined in accordance with the following equation. So you can see here the particle in the before the particle earthquake is given the positive side. So EM is nothing but the total seismic load effect including overstrand factor, and EM H is the horizontal seismic force defining in section given 2.5.7 or 2.579 including structural overstrand, and if you know the effective vertical seismic forces. So you've been seen here. So I want to draw attention that only only combination 5 is mentioning here. The combination 5 we are using plus below before the vertical. So that's why we've been using plus. So we are, if we adding this value with 1.2, then we will get the 1.29. So that's why I'm not taking here the dead load again, because we are just moving this dead load is here. All the dead load we have been taking in this way, in these places. So that's why we have been taking positive, and we are also vertical we have been calculating also here. We have been seen here vertical is the same, it is 0.9, and we are using the minus value. Why? Because this combination we've been seen here use for the use of load combination 7. So we've been seen here that this is the 7. So this is the 7 and this is the E of 7, not 5. This is the load combination of 7. Okay, so we've been seen use in load combination 7 section 2.7.3 or load combination in 8 section 2.7.2. E shall be taken equal to EM and determined in accordance with the following equation. The equation is given. EM is also the total, and ES is the horizontal seismic force, and EB we know the vertical load. But remember that we have been seen here clearly the combination when using 7, then we've been using the negative sign before the using vertical earthquake. So that's why we are using the negative sign. Where it's only for a load combination 7 here. So let's go to the load combination 7. This is the load combination all the 7, and this is the we've been from vertical load. We have been already shown how we'll get the vertical load, and we're just using this formula and found the vertical load and found 0.09, which is, and it will be minus 0.09. So we are just deducting 0.09 to minus 0.09, and then we will find 0.81 dead load. This is the final outcome, 0.81. We are not writing here because the all dead load is coming in this here. So I'm just and then finally I'm just putting all the load is here, such as number 1.2 dead load. Here is a 1.2 dead load, 1.2 dead load plus 1.6 live load and 1.5 roof load, and this is the second, and this is the third, this is the fourth, and the fifth one we just copying this value all through this here from 4 to 7. So you can see here from 4 to 7 we just keeping all this load combination here, just copying this value here and taking this value here for the appearance in good appearance. And this way also we're just copying in the upper, and this also has been found 2.9, and this way and this way. So these are the final load combination. So I've been just making another Excel. These are the Excel. This have been seen the load combination of seismic design category C, B, D as per BNBC or ASCE 7 ASCE 7-05. these are the 7 load combination, but we are calculating here it will be 31 load combination. I'm just seeing how we'll get how we have been get the 31 load combination from 7 load combination. Okay, so we have been just seeing here the 7 load combination, and we just if we just changing the value of z, such as we are just using z below 0.36, which is the severe zone 4 or severe zone 3. Then the value will be changed. We've been seeing 1.16, so the value of dead load also will be changed 1.36, and this will be 0.74. And if we change the soil factor, which is S1 SB SC, then if we found the maximum value 1.4, then it will be also changed 1.7. Then we can see here the dead load also will be changed, and these are the load combination 5 and 7. This is the 5 and 7. The dead load will be changed, but this the vertical horizontal load will be as it is same in x direction and y direction. So these are the lecture is intent. If you need this Excel, you just call me, or you just message me or comment me. I will just I will provide this Excel. Plus, please subscribe my channel also. So these are the lecture in that. I hope that you can understand. If you need any kind of these documents or paper, I will just give you. You just change this, and you just change this value of z as per your code, as per your location, and soil classification as per your find. Then you will just you can get the actual load combination of 31. So this is the 31 load combination for a load combination seismic design category C, B, and D. Okay, thank you everyone. If you have any question, then let me know. I'll just try to answer your question. Thank you.